Most SwiftUI task apps look fine, but they are built wrong. They work in tutorials, then collapse as soon as you add real features. In this video, I'll show you how I structure task apps in a real SwiftUI project. The first thing we need to do is to create our task priority enum. The purpose of the task priority enum is to show if the task is urgent, medium, or of low priority. So we'll create a new group, name the group enum, and then we create a new Swift file and name the file task priority, and then enter the following: enum task priority int. We want it to be codable, case iterable, so we can loop through it. Each of the enums will have a unique identifier. Case low is 0, medium and high. We also need to create an ID for identifiable, so that each of the enum values have a unique ID when we're looping through it. For value, and then we create a computed property display name, which returns a string. Switch cell, return low, as in low priority, so that should be case low. If the case is medium, then we return medium as a string, as a medium priority. If the case is high, return high as a string. The next thing we need to do is create our data models. So we need to create a new folder called models. And the name of the data model will represent the information that will be stored in SwiftData. So because it's a task management application, we need to name the first model or entity task item. We also need to import SwiftData and decorate the class with @model. That will signify that we're using SwiftData, and the class needs to be like persisted as a data model for SwiftData. The data table or the entity has an attribute which will be a unique ID using UUID, and we also have a title for the task, and the task can also include notes, and it has another field called completed. That's a Boolean variable that will signify if it's pending or completed. The task also has a start date, when the task should be started, and the task has an end date as well, and also a project type or a category that you'll see later. And it also has a private variable called priority, which is a raw value of integer data type. And it also has a color hex string to store some colors, and a created at date that will show when the actual data was stored or saved within SwiftData when the actual task was created. Var updated at that will show when the task was updated, the actual date and time. We also need another computed property called task priority that we created earlier, and then we have to use a get, so it's a read-only property, task priority raw value priority raw medium. So that will convert the raw value into a task priority, and then we use a write property, which is a set property, priority raw I spelled priority raw incorrectly, so that should be priority let me go to the definition. It was defined there. So it should be priority, so that should be there should be an I there. It's correct now. So that's priority raw, and then we assign the value as new dot value to get the raw value. We also need to apply our initializer. So for the color hex, that should be assigned to this string. And priority raw should be, do we need priority raw in there? Yes, we do, but that should be dot raw value. So it should be priority, and that should be priority dot raw value. Yeah, that's it. And then the issue is that our parameter within our initializer states priority raw, but it should be called priority. And priority should be a task data type and not integer. See, that's why I like to do some of these things manually sometimes, because sometimes Xcode, it doesn't work properly. As I use autocomplete for the initializer. Just going to double check everything now. UUID, UUID should be UUID. Title string. Note string is completed boolean, which is assigned to false. That should be false. Just compile it again. In the next tutorial, we will implement more models and the repository. The next model we need to create is our task input model. And the purpose of the task input model is to enable each task to have the right attributes when we're storing and saving and retrieving the task. So the first thing we need to do is to create a new Swift file within our models. Click on Next. Name the model task input. And then I'll just copy the model from the clipboard. So the model's been pasted. So this model will pass most code reviews, and this is exactly why most SwiftUI tasks apps fail in production. This struct, this model is incomplete, it's wrong. It's just a bag of values. It doesn't enforce a single rule about a valid task. We will now refactor task import to enforce rules. So the first thing we will do is to create a new property called validation error bar validation error string. If title dot trimming characters dot white spaces, so remove any spaces from the string. If it's empty, then we just return title is required. As you can see, we're now validating the title property. If end date is less than start date, return end date must be after start date. If color hex is equal to nil, return invalid color value. So if you do not put these rules next to the imports, you will scatter validation across views. Scattered validation is why task apps fail and become inconsistent and buggy. We also need to add a return nil here. And also a var is valid bool validation error is equal to nil. We have to also import SwiftUI so that we have access to the color class. We need to create another folder called extension because we need to extend on the color. So create a new group and just name the file color plus extension. So that's the name of the folder. I needed to add a Swift file. So create a new file, select Swift file, and then add the file to be color plus extension for the Swift file. Click on create, and I'll just paste what's on the clipboard. And then now, the file that we created, it should compile. Let's try it now. It compiles. The next file we need to create is our task repository protocol. So let's create a new folder, a new group called protocols. And then create a new file, Swift file called task repository. And I'll just paste everything that I have on the clipboard. So this protocol looks boring, and that's exactly why it matters. Most SwiftUI tutorials skip this and talk directly to SwiftData or core data. That works until your app grows. Notice this doesn't accept a model object. It accepts an import. That's intentional, and that's where most apps go wrong. If your UI talks directly to the persistence model, refactoring becomes very difficult. And the same applies with migrations, and that's normally where the app dies. The next file we need to create is the SwiftData task repository file. So we just create a new folder for that, just call it repository, and then create a Swift file, give it a name, SwiftData task repository, click on create, and then I'll just copy everything that I have on the clipboard and then explain it. This is the part most Swift tutorials either skip or tightly couple within their SwiftUI. This struct is boring, and that's exactly what you want. This app doesn't depend on SwiftData, it depends on a contract, and the contract is task repository. The UI never creates task item, and that's intentional. The repository owns the persistence model, not the UI. Every write operation is explicit. There's no magic, no hidden save, no side effects. This signals reliability and predictability. In this tutorial, we will implement the view models. So the first view model that we will create is called the upcoming view model. And the purpose of that view model is to show the tasks that are upcoming. So we create a new Swift file. Name the file upcoming view model. And then I'll just paste what's on the clipboard. So what's happening here? The first thing we do is to include the main actor. The main actor, which is on lines 10, prevents an entire class of bugs. Every state mutation in the view model happens on the main thread by design. Most SwiftUI bugs I see in production are threading bugs, pretending to be UI bugs. As you can see, the view model doesn't know about SwiftData. It just knows about the contract, and the contract is within the task repository. So that's the difference between an app that evolves and one that gets rewritten. Also, within the initializer, the view model owns its data lifecycle. The view doesn't trigger loading, and that's deliberate. The view comes and goes. State shouldn't. And also, for the load method, notice there is no partial state here. Either we have the task or we have an empty consistent state. And the function filtered for selected date. It filters the tasks to only those matching the selected date. The logic does not belong in a view. If you filter in SwiftUI view, you will duplicate the logic. Duplicated logic is how behavior drifts happen. And on line 47 for the task function, this is where the view model lives. This can be tested without SwiftUI. View should be questioned and not answered. Now that was an error. View should ask questions but not answer them. So that's for line 47 for the task function. The next view model we need to create is project task view. So I'll just create that view model now. So the purpose of the project task view model is to load the tasks from core data and also delete the tasks in memory, and also to enable the user to reorder the tasks. So let's create the view model now. Project task, view model. I'll just paste what's on the clipboard. So we first create the main actor here, which is needed to enable all UI state updates to happen on the main thread, like in the previous view model. And within our initializer, this is where the first code smell happens within production. SwiftUI does not guarantee the view model is created once. Every time it is recreated, load runs again and again, as you can see here. And this is how you get duplicate fetches, flickering UI, and wasted work. Although the load method is a simple method, but at the same time, that's the problem. There is no loading state. There's no retry logic within the load method, as you can see. And also, errors are just strings. In production, this gives you UI state you can't reason about. Also, within the load function on line 31, this works perfectly until the app restarts, because this order is never persisted. As you can see, there's no repository.save or any persistence going on. And also, persistence ordering would require an order index property. And this is also one of the common SwiftUI performance bugs, since every small change triggers a full reload for the toggle and for the delete. With 10 tasks, you won't notice anything, but with 1,000 tasks, the app will feel broken. So delete reloads everything. As you can see, it's a simple function, but it's also wasteful. In production, you either update local state optimistically or pay for it. So what we will try to do now is to do some refactoring to get this view model how it should be. So the first thing we need to do is to update our published variables so that they're right properties using set. So I'll just type that manually. Private set var tasks. So we create a new task item array. And we do the same thing for the error messages. For the error message, make it set. And also we need to create another variable called didLoad, private var didLoad equals false. And then we can update the load function because it needs to be, the load function on line 21, it needs to be load if needed. That function doesn't exist at the moment, so we need to create that function. I'll just create that now. Function load if needed. Also need a guard statement. Guard not did load, so if it didn't load, then we just exit the function. If it did load, then did load is assigned to true, and then we just call the load method. Within the load method, we also need to do a little update as well. We need to display the error, assign the error message to nil. And also we need to clear our array, empty our array. And for the toggle completed method, we need to do the following. So just type in guard let index equals task dot first index. So we're attempting to locate the record using the ID to ensure that it's equal to the ID of the task. And if it's not found, then we just exit the function. Oh, that should be task there. Next thing we need to do is an optimistic update. So we need to assign the task index is completed to toggle. So update it so it's either true, false, as in the task has been completed. And we need to do the same thing for the delete function. So I just copy what we've done for the guard functionality and then paste it in the delete function and then type the following: let removed equals task dot remove at index. So it removes the task using a given index. And then if an error happens, we need to do the following: task dot insert removed at index to remove the record that was inserted. So that should be loaded if needed with a capital I. I'll just compile it. It's compiled. The next view model we need to create is the edit task view. And the purpose of this view model is to enable the application to perform updates and deletes so that we can insert a new task or delete a new task. Edit task view. Edit task view model. And I just paste what's on the keyboard. That's on the clipboard. So as the view stands at the moment, the view model is clean, it works, and it is exactly how most task apps end up, shipping subtle bugs. So let's go down to the save function. As you can see, the save function returns a boolean. Using a boolean is not really friendly error handling because the UI cannot tell if this action failed due to validation, persistence, or something recoverable because it only returns a boolean. Also, on line 54, validation is only performed on the title before saving. In production, users will absolutely end up with end dates before start dates, invalid colors, empty projects, and you probably store a lot of garbage that way in the application. So let's improve this view model. I'll just paste the code from the clipboard. As you can see, we've made a few improvements. Now the save function returns a result with an error and not a boolean. So because it's wrapped within a save result, it enables us to have access to other type of information, not just boolean data. And that's something what the UI can work with as well, so the users understand the application. This is what a real task app looks like. Fewer branches, fewer places to forget logic and state. and it makes it easier to trust the application and to work within the code base. In next week's tutorial, we'll be implementing the reusable UI components. That includes like daychip, app themes, colors, and everything else. In this tutorial, we'll start to implement some more features, such as our haptics. So now let's create another new Swift file within our enums folder. Name the file haptics. Import SwiftUI. Type the following, haptics. So the purpose of the haptics is to enable feedback using vibrations. Static func success. UI notification feedback generator. Notification occurred, and we pass a success, and then we do the same thing for error, but this time we pass error. UI notification feedback generator. Notification occurred, and then we send an error. The next thing we need to do is to create another file, and this will be for our app theme. Import SwiftUI. And the purpose of our app theme is to show the different colors that our app will include. Enum app theme. So this will be a static let background equals color, UI color, system group background, and then we create another color, and this color will be for our cards. So the color will be a secondary system background color. And also we need a color for our separator, and that will be a color primary opacity of 0.08. We also need a red color, so we need to use red 0.98, green 0.36, and blue 0.39. We also need a custom orange color. It's a bit similar to the previous one, so I just copied the previous line. Green will be 73, blue 39, and then we need a blue color, which will be static let's blue equals color. So the red will be 35, the green will be 55, and the blue will be 98. The next file we need to create is our daychip view. The purpose of the daychip view is to enable the user to visualize the actual date that they can select from the calendar to assign to their task. So we need to create another folder, another group, name the group views, and then create a new SwiftUI file. Call it daychip view, and then I'll just copy and paste the code from the clipboard and then explain it. So here is the code. As you can see, this code looks clean. This will pass most code reviews, and this is exactly why most SwiftUI timeline UIs fail in production. So this struct is not wrong, it's just that it's incomplete. It includes a bag of values. It doesn't enforce a single rule about how a day should be displayed. Nothing here guarantees consistency, as in the information formatted correctly within the app. And nothing here guarantees that the locals or the calendars will be consistent. Nothing here prevents dark mode visual bugs. And the most important thing is that this view quietly makes decisions, and it shouldn't. As you know, the actual decision should be within the view model. In real apps, the UI state is hostile. If your view makes assumptions, inconsistencies with your application will occur. Also, this works in tutorials because tutorials don't scale, production apps do. The first problem is on lines 11. Passing the date directly into a view feels harmless, but it quietly pulls formatting and calendar decisions into the UI layer, which is wrong. And another issue on lines 14, it seems right using the date formatted that way, but it's wrong. The static avoids formatter recreation, which is a good thing, but hard coding date formats ignores local, calendar, and user preferences. As you can see, we have hard coded the date formats in the actual UI. Also, within the view body, there's a few other issues, such as vertical layout for weekday and day number. This layout assumes 2 short strings forever, and we all know that views and information grows and shrinks at any time because the information is dynamic. So this is also incorrect. And there's also no validation or fallback within the view. As you know, all of that should be applied within the view model. And the hard-coded color is also incorrect for the background. It will work until it doesn't, such as if we change it to light mode. So now I will include the refactored version. I'll just copy it and paste it from the clipboard. It's the same day chip. Let's see if it loads correctly in the preview. And yes, it does. That's a selected date, and that's not a selected date. That's why it's duplicated, as you can see in the preview. So I'll just delete the code that we had earlier to make the file neater. So as you can see, we still accept the date, but that's still correct because this is a calendar chip, but we immediately convert it into a display only value. And also with the formatting for the date, or for the dates, for the day number and the day label, you can see that the formatting is consistent and explicit. Every screen uses this chip will look the same. And for the day number, there's no churn, there's no hidden logic to do the calendar, which is correct. And for the actual view, in the body, it renders strings. It doesn't ask where they come from. And also for the accessibility, we handle it correctly. which is from one source of truth. In the next tutorial, we will continue to implement more of our reusable views. The next view we need to create is our timeline events block view. The purpose of this view is to enable the user to be displayed with a list of tasks as seen here. So if they had, like, for example, 4 tasks on this date, then there'll be 4 tasks within this list with the selected or related time on the left hand side. So as you can see, the timeline event block view, it looks clean. This would probably pass most code views, and this is exactly where most timeline UIs fail. This struct is not wrong, it's just incomplete. It doesn't enforce any single rule about how a timeline event should behave. Nothing here prevents expensive work during scrolling. Nothing here stops inconsistent time formatting across the app. And nothing here prevents the main logic leaking into the view. And most importantly, this view blindly trusts the task model, which is this one here. In real apps, scrolling this view could become very hostile and bugs would occur within the application and also performance hits. So now let's look why this is very error prone. At first glance, this feels convenient by passing in the full domain model. As you can see on line 12, we pass it into the view. But the issue is it gives the view permission to do too much. Another issue, formatting the time range. It looks correct, but there's a problem with that too. Every time the view renders, a new time formatter object will be created. And also, this extension should be within its own file. So let's move that now. Let's create a new Swift file. Name it task priority plus the extension. Click on create. And we'll just move that block of code. Now that still looks a little bit better, but we can still improve the code a bit more. So let's try to refactor it. So I will copy and paste the code from the clipboard that includes the refactored version. So here's the refactored version. Have you noticed what has disappeared? There's no data formatted. There's no data formatter created during rendering, as you can see. There's no domain model leaking into the UI. And most importantly, this view cannot be misused. In production, your timeline must be cheap to re-render. If it isn't, it will stutter and become very slow. So this is the boring version, and boring is what ships. The timeline arrow row view looks harmless, but this is already a design smell. The view accepts a real raw domain model, as you can see. Once a view accepts a task item, for example, it becomes very easy to accidentally depend on it. And also the on-tap task fallback is also another issue, as the callback leaks the domain model back out, and this couples the UI layer to the persistence decisions. Other issues includes the for each. As you can see, the for each includes a mapping and also persistent scrolls that will degrade the performance of the application. And also on lines 30, we're converting a persistent model into a UI contract. It works, but this is exactly where logic creeps in. And this also happens on line 31, where the gesture sends the domain model back up. Now the caller must understand the task item too. And this is also how tight coupling spreads throughout the application and also makes it less testable. So now we will try to resolve the issues with a new version. Have you noticed what has disappeared? There's no task item, no formatting, no parsing, just rendering. In production, views are not where you do work, views are where you show results. And this is the boring version, and boring is what gets shipped. Here is the code for the project task row view and display. So this is production code, not because it's fancy. It's not fancy, that's not the reason. Because it's cheap. The view does one job, which is to render a UI contract. There's no task item in the view, and there's no SwiftData in the view. There's no date formatter in the view, and there's no hex parsing in the view. And this means that scrolling stays smooth. In production, list rows must be cheap to render. If they aren't cheap, they will stutter and become very slow. So yeah, again, this is the boring version of the app, and this is the type of feature that would ship. The edit task view is the most important screen in the app because this is where user input enters the system. If the screen is sloppy, everything downstream becomes unreliable. Dismiss is a dependency. We don't reach for navigation hacks, we use the environment. And the same with the at-state objects. The view model owns the form, and the view just renders it. And the focus field is used to track which text field is currently selected. And focus state is also a production polished way of doing this type of thing. And also, this optional callback keeps the actual view reusable because it enables the callback to be called as in the caller decides which save is to be used or what save really means. Also, this initializer supports both save and edit features of the application. And also for the pickers, especially on line 64. This is where production apps fail. If your view model doesn't enforce the end date to be more or equal to the start date, then the UI will allow invalid tasks. So to make this app, this view, production ready, we've done a few changes without changing the actual view model. So one of the changes that we've done is to prevent double saving by using is save as a boolean, and we've also added a single save path, which is a path of truth. That's called attempt save. As you can see down below in here. And we've also added a UI level schedule clamping to stop obvious invalid states. And the other things that we have done includes, see if I can find it, using can save. So this is a UI guardrail. The view model must still enforce the rules. On lines 46 to 50, we clamp obvious invalid schedule states at the UI layer, and we still validate in the view model. And as mentioned earlier, this is one code path for saving and will not create any duplications. And also, the production version allows done to trigger save when valid, as you can see here. And as you can see, here is the actual preview. The next view we need to create is the upcoming view. As you can see, this looks clean. This will pass most code reviews. And this is exactly why most SwiftUI task apps fail in production. I know everything looks okay at the moment. It's all functioning. With the at-state object on line 12, this part is correct. The view owns a life cycle. On lines 15, Hard coding hours work until the time zone and DST gets involved. So that would also fail in production. Line 16. That includes good dependency injection. Which is good because that means the view doesn't talk to the persistence directly, doesn't talk to SwiftData directly. This looks like UI, but it actually is a business rule, this feature, so that function should really be within a view model. So this would need to be refactored. And also on line 65, this one here, this is also a good move, mapping domain to display the model. And here's a crack. As you can see, we are converting the UI back into a domain by getting the identity. And this, between lines 88 and 94, is a real app behavior, which is a cross-tab state update. Notice we do not reload, then select to avoid stale UI. Since we're also always refreshing the reload feature, the data on the screen is always correct with the latest changes. And also with the dot on a pair, it's fine for now, but in production, load all gets slower. You'll want loading state and async to work seamlessly. And the state drives the presentation cleanly. And also here on lines 196 to 200, data formatter here should be cache. It could be a small improvement, but at the same time, it can degrade the app if you don't include these type of improvements. And the next thing we'll try to do is try to refactor some of the code. This is a production improved version of the upcoming view. I've refactored the parts that cause real bugs in the wild, such as the DST hours, tap determination, formatting costs, accessibility tabs. But I'm leaving a couple of things intentionally unfinished so you can see what almost production still looks like. Here's a production fix for day hours, which is here. And here's also another production fix for DST hours. And also we have another production fix to build the lookup per row using the dictionary, which is here. And it's not inside the closure. And this enables stable mapping. It's built once. And also the taps, they do not do the work. Also, there's another fix down here somewhere. I think it's to do the unchange. Yeah, here it is. This one here. So the external input is a sync trigger. We select and we refresh once. And this is the completed file, as you can see. So the next one we need to create is the project task view. As you can see, this code looks clean and it would probably pass most code reviews as well. But there are two production traps hiding in plain sight, and they are filtering and reordering. And this is one of the functions that needs to be refactored. Filter tasks. You can see the code is readable, but in production, filtering inside the view can get very expensive. It is fine until the actual view starts to grow. And there's another issue. which is to do with dragging. Let's see if I can find it. Where is it now? Oh, here it is. This part here. So this is another second production trap. We're mixing filter UI positions with source of truth positions. And the thing is, this will work until the user is searching or filtering. Then reordering becomes inconsistent. So we will now try to fix those two issues. And this is the production improved version. The biggest two production traps are now fixed. They included filtering and reordering. But it's not about the final production. It's about fixing the correct errors that could hinder the application in a big way. Such as things like UX and reordering while filtering. That can be very dangerous. So here is a production fix on line 35. We never use filtered indexes for reordering. Filtering is for rendering, not for the identity. And also for the handle drop function. This is a real fix. We reorder in the source of truth array. Filtering never affects the move maths. And everything else stays the same. In the next tutorial, we'll be focusing on the navigation routes and also things to do with the root view and tabs. Most SwiftUI task apps look fine, but they are built wrong. They work in tutorials, then collapse as soon as you add real features. In this video, I'll show you how I structure task apps in a real SwiftUI project. Within the app root view, we are using enums for the tabs, which is already the correct way of doing things. It is strongly typed tabs, which scales better than raw values and prevents a whole class of bugs. So that's a good thing. And here is the first hidden problem on lines 21 to 23, which is the model context is injected at the app root, which means everything below depends on it. So this looks clean, but it is deceptive. This repository is recreated based on the view lifecycle, not the app lifecycle. On lines 25, this is the single source of truth for the tabs. So at the moment, that is okay. But at the same time, this is where things can get a little bit risky. On lines 29, this is a tab view, but it's important to remember tab view is state-driven. It's a state-driven view, switching, which is not true navigation. And also the screen depends on state that can be mutated from a completely different tab. On lines 43, we are using the calendar focus state, which is similar to a mutating share state that another tab depends on. And this works until it doesn't. So now we will attempt to improve the app root view. So I'll just copy and paste the code I have already created into the file. Just wait for the preview to work. So one of the first improvements that we have done, we have included the coordinator, which is strongly typed for tabs, and it's also non-negotiable in production-ready apps. It scales cleanly for navigation and avoids any magic values. And the other advantage is that it only has one intention, one place where side effects happen. This is what keeps tab navigation predictable. The coordinator is also owned by the app shell. This guarantees stable cross-tab behavior for the lifetime of the UI. On line 35, the factory keeps repository creation explicit and testable. And for the init, the initializer, it makes the app shell more friendly to test. In production, you can inject mocks or previews without changing the view. And within the body of the view, the repository is created once per view instance. If you need app-wide lifetime, this moves into an app container. And also here, the tab observe state. It does not decide the actual navigation. And on line 61 to 62, the view expresses intent. It does not mutate tab or navigation state directly. So the next thing we need to do is to open our app file, this one here, and then we need to type in SwiftData, import SwiftData, delete the content view, type in the following app root view because this will be the startup view, and then we pass the model which is task item.self. Just see if it compiles, if the preview is still working. It should work. And yeah, that's how you can create a production ready task application.